All right. Good morning, folks. Let's go ahead and let's get started. Let me go ahead and start my timer. Let's go ahead and let's get started. And what I would like to do, and the goal for today, then, is just to finish up with the naming and coming up and the formulas. And so we want to finish that up so I can go ahead and focus in tomorrow's lecture. We'll focus in on the properties of ionic compounds, and then I want to quickly go over metallic bonds. So we will finish up this chapter tomorrow, which means then Monday we'll review for the exam, and then Tuesday. So I got to move it back one day just to make sure that we can cover everything. Okay. All right. So let's go ahead then. Let's dive right into this, and let me go ahead and share my screen with you here. Let me open up my notes here really quickly. And so we were talking yesterday about how we write down formulas, so formulas for binary compounds. So we finished up yesterday learning about how we can write down the names. If we're given the formulas of binary ionic compounds, we should be able to come up with the names. So we learned how to do that. Hopefully you had a chance to practice that as well. And then what we started doing yesterday was that if we were given the name of a binary compound, we should be able to write down the formulas. Okay? I think it's just a tad bit more work than writing out the formula, the name given the formula. I think writing out the name should be pretty straightforward. I hope that shouldn't be too difficult. Writing out the formulas it's a tad bit more difficult, but if you practice it, it becomes pretty straightforward. And as a matter of what we will be doing moving forward, actually writing down the formulas, what we will be doing today is a little bit more important because when we get to chapter 11 and we're doing the stoichiometry and we're doing the calculations involving chemical quantities, we really need to be able to get the right formula. So what we're going to be doing today then is we're going to really focus in on that. Make sure that you are capable, that you can do this by the end of the lesson. And then if not, please make sure you come by and see me. So that the goal for today then is we're going to focus in on writing out formulas. We'll talk about the non-binary compounds as well, how we come up with the names for those, and also the formulas. But we really want to focus on the formulas. Okay. All right. So let me go ahead then, and let's take a look at the. Let's continue. Let's pick up where we left off with yesterday. Okay. So let's take a look at this particular compound here, the name of which is calcium sulfide. And so I'm going to run through these fairly quickly so that we have time to go over uh, everything today. Okay, so let's go ahead then. Let's take a look at this here and let's go through each one of these questions. Is it a binary compound? I think you should recognize that it is. Calcium is one element. Sulfide, sulfur is the other element. So we have then a binary compound. The answer there is yes. Okay. So with that said then, is this binary compound ionic? And we need to answer that question in order to answer questions 2, 3, 4, and 5. So I'm sorry, actually through the rest of it, 2 through 6. Okay, we need to be able to identify that this is an ionic compound. And how do we identify that this is an ionic compound? Well, this compound here is made up of two elements. One is a metal, and one is a non-metal. Whenever you see a metal and a non-metal combined together in a binary compound, you know that this is going to be an ionic compound. So with that said, then we should be able to identify the cation fairly easily because that the cation is always the first one is always listed first in the name. So therefore, the cation that is going to be the calcium cation. Okay. And once we have that, we should be able to write out the symbol for the calcium cation. And this is going to be very important. If you are able to identify this, then hopefully you can go from that step 2 to step 3. You got to be able to write out the symbol for the cation. Okay. All right. So what that means in the sulfide is the anion. So this is the sulfide anion here. And based on the name here, we should be able to write out the symbol for the sulfide ion. And it's going to be S2 minus. Again, if you're having a hard time going from 2 to 3, going from 4 to 5, you really got to come by and see me, and you really got to practice it because moving forward, the assumption that I'm going to make is that you can just be able to do this. So if I say calcium, you should be able to write out this ion. If I say sulfur, you should be able to write out this ion. Okay. All right. So with that said, then these two ions have to get together. These two ions have to get together to form this compound. Okay. So therefore, they go ahead and do that. Okay. And so the question then is, will the charges balance out? That means the charges equal 0 if you have one of each ion here. Okay. If you have one calcium, it has a 2 positive charge. One sulfide, it has a 2 minus charge. And so yes, you only need one of each one of those ions in order to get to the neutral, in order to make a neutral compound. Okay, and so we write it that way. Okay? We write it then as calcium with 1. Remember, if there's nothing written, if there's no subscript written here, it's implied to be 1. So therefore, that is the formula then for calcium sulfide. And again, it's this skill here, being able to obtain this formula from the name, that yes, it's a tad bit more difficult. It's a little bit more difficult than getting the formula, getting the name from the formula, but it is also a more important skill. So you got to be able to get this done. Okay, so let me go ahead and save this. And what I'd like you to do then is just like what we did with the previous problem. Let's go ahead then and let's take a look at number 14 from your problem set. Okay, let's take a look at number 14 from your problem set. And what I'm going to do here, I'm going to work through the first 2 for you. I'm going to do 1 and 3 for you, and then I'm going to ask you to do 2 and 4. Okay. All right. So let's go ahead and let's take a look at each one of these here. Let's take a look at number 1. Let's work that out together. First question: is it a binary compound? Yes, it is. It's a binary compound because it is made up of 2 elements. Okay. Potassium is the first element, and nitride or nitrogen is the second element. So it is a binary compound. Okay, let's get that out of the way. Is it an ionic compound? Well, if we weren't given this name, obviously in direction, it's already told, you're told that. Okay, but if you're not told these are ionic compounds, you should be able to recognize that potassium is a metal. Okay, and nitrogen here is a non-metal. So we have a metal with a non-metal together. Absolutely, this is an ionic compound. Okay. Next step, what is the cation? Again, the cation is going to be the metal, and the cation is always going to be listed first. So potassium is going to be your cation. Potassium will be your cation, and the symbol for potassium then is going to be K plus. K plus. Okay. Then the anion is the nitride anion. Okay. And so therefore, if you're given that, you should be able to write out the symbol for the nitride ion as being N3 minus. Finally, I'm sorry, the next question, the penultimate, the next to the last question, we have to ask ourselves, if we had 1 potassium, okay, and we had 1 nitride, would we achieve a neutral charge there? Okay, would we get a neutral compound? And obviously the answer is no here, you guys. The answer is no, because if you take a look at this is going to be a +1 charge. This is going to be a 3 minus. We'll end up with a 2 minus net charge, not 0. So we cannot have that. So how can we achieve then a neutral charge? Well, hopefully you recognize here then that if we had 3 potassiums, not just 1, but if we had 3 potassiums, then we'd have a 3 plus charge here. That would balance out the 3 minus charge here, and therefore then we get a net charge of 0. Which means then when we go to write out the formula, we have to indicate then that we have 3 potassiums and 1 nitride. And if you notice here in the formula, we do not include the charges. Okay. All right. Now, if you notice here, and the shortcut that you can take here then is, if you notice, if you take the number of the charge and you just bring it down to each side here, that's what you get right there. Okay. All right, very good. Let's go ahead then. Let's take a look at number 3. Okay. Number 3, is it a binary compound? Yes. Iron is one element and oxygen is the second element. Is it an ionic compound? Yes, because iron is a metal, oxygen is a non-metal. So there we have it. We have an ionic compound. Okay? A binary ionic compound. Okay. So what's the cation in this? Cation is going to be iron 2. Remember the stock system. That 2 that indicates the charge on the cation. So we have an iron 2 plus and oxide. You need to make sure you remember then that that's going to be 2 minus. So, all right, so will one of each of these here give us a net charge of 0? And the answer is yes. This is 2 plus, this is 2 minus, so we can go ahead then and write out the formula for the compound as FeO. That will be the formula for iron 2 oxide. Okay. Again, now if you cross the charges here, if you go ahead and you do that little trick here, if you cross the charges here, and you bring the 2 down right here, you can still get to this answer, but you got to be mindful of one thing here. You got to be mindful of one thing, that if you cross the charges, you get then Fe2O2. And now remember, you can't leave it that way. You got to make sure you reduce or divide by a common denominator here, divisor here. And if you do that, you get the lowest whole number ratio. These two are not the same because this one is twice as much as this. You got to get the simplest whole number ratio. This is not simplified yet. So if you go this route here and you decide to cross the charges, do not leave it this ways. You have to reduce it if you can. Okay? All right. Very good. Let me go ahead and let me leave that up on the screen for you. And let me ask you to do this. Let's take about 2 minutes. I would like you to work on, so it's your turn now. I would like you to do number 2 and number 4. I did 1 and 3 for you. I'd like you to do 2 and 4. Now, do you have to go through all of this, all of what I did here for you in order to get to the formula? No, you don't. If you can get straight to the formula and if you can do all this work inside your head, okay, then please do so. That's the point we want to get to. But until you get to that point, please keep doing this. Okay? And on the exam for this chapter, I'm not going to ask you to do all of this. Okay? I'm not going to ask you to show me all of what I'll indicate here for you in red here. Okay? You do not have to indicate. You don't have. This is not the work that I would like you to do. That's too much. So whatever's in that red box right now, you should be able. You should get to the point where you're doing that in your head. Okay? So if you can, perfect. If not, please work it out that way so you get the correct formula and keep practicing doing it that way until you get to the point where you don't have to do it. Okay, so I'm going to leave this up for you. Let's please go ahead. Let's do number 3 and 4 in your problem set. Number 3 and 4 in your problem set, and then we'll come back after 2 minutes and we'll work it out together. Okay, go ahead, get started with it. All right. Let's take a look at this. Okay, so let me go ahead and let me clear up the drawings here. Let's take a look at number 2. Let's do calcium bromide, and let's work that out together. So I am going to do all this work for you only because I want to remind you of the process that you should be doing mentally. Okay, so binary compound, yes. Calcium is one element, bromine is the second element. Is this an ionic compound? Yes. Calcium is a metal, bromide is a nonmetal. Okay, so the bromine is a nonmetal. Okay. All right. Cation then is calcium, 2+. Okay, calcium cation. Okay, bromide anion is going to be Br with a 1-. Okay. Right. Then will one of each here get us a net charge of 0? If you notice here, obviously you can't. You'll need 2 of the bromides and 1 of the calciums to get us a net charge of 0. So therefore, the formula then is going to be CaBr2. Okay. All right, and again, crossing the charges in this instance will get you the lowest whole number ratio. That does work, and so you can just go ahead and do that as well. And you can do that mentally. Again, like I said, though, this here, what I did here for you, where we are assessing the charge, that's what you probably should be doing. That's the more precise way. That is technically the correct way to approach it. Crossing the charges is this quick little trick that you can use. Okay. All right, let's go ahead then. Let's take a look at copper 2 sulfide. Okay. All right. Binary compound, yes, check that off. Okay. Ionic compound, yes, check that off. Copper 2 is a metal. Okay. Sulfide is a nonmetal. Okay. Let's go ahead then, write down the symbol for copper 2 for the cation. Copper 2, Roman numeral 2, means that it's a 2+ charge. Sulfide is a 2- charge. Again, you have to make sure you remember that. Okay. Will one of each of these here get us to the neutral charge? Yes. So therefore, we'll indicate that with no subscript here. So that is the formula for copper 2 sulfide. Okay. And again, if you choose to cross the charges, make sure then that you reduce it to the simplest whole number ratio. Okay. All right. So that wraps it up for binary compounds. So what we've done up till this point, we've learned how to write out the names of binary compounds. If we're given the formula for binary compound, we learned how to write out the name of the binary compound. If we're given the name of a binary compound, we learned how to write out the formula for it. Okay, so make sure you keep that in mind, because what we're going to move on to now then is we're going to start talking about non-binary compounds, and that is compounds then that are made up of more than 2 elements. Okay? And so again, we're not counting atoms here, guys. We're counting elements. So with Non-binary compounds, that is compounds that have these polyatomic ions. I refer to these as non-binary compounds. Okay, so I'll be referring to these from now on as non-binary compounds. So these are the non-binary compounds. Okay. What makes them unique is that they have polyatomic ions. Now remember, this list of polyatomic ions you had to memorize, and I'm hoping that you are going to memorize these. But the idea there is that if you had studied them, if you had looked at them, almost all of the polyatomic ions are anions. Okay? They are all anions, which makes things simple for us because the cation will always be a monatomic cation, and we just name the metal. Okay, there was one exception, and that was ammonium. Ammonium is a polyatomic cation, and that you got to make sure you keep in mind because that's going to creep up on you, and when you least expect it, okay, you won't be able to recognize it, and you'll get it wrong. Okay, so please make sure you memorize these. Okay, all right. So naming these, the rules then that we'll use to name these non-binary compounds is almost identical to what we use to name the binary compounds. Again, the only difference now is that the name of the anion we have to remember. That has to be memorized. It's not a matter of dropping one portion of the parent name and adding the suffix in. You have to memorize the polyatomic anions. Okay? In the same way, you got to memorize ammonium, and you got to be able to do that. Okay? All right, so if you take a look at this particular compound here, it's sodium bicarbonate. This is baking soda, the baking soda we use in cooking and at home. Okay? So if you notice then, this is not a binary compound. Why? Well, first of all, if you notice that sodium is an element, so that is a single element, but there is no element called bicarbonate. You look on the periodic table, there is no element called bicarbonate. And so as soon as you see that, and again, hopefully you've memorized it, as soon as you see this bicarbonate here, you should already recognize that this is a non-binary compound. It is made up of, which means that it's going to be made up of more than two elements. We expect then that it's going to be more than two elements. And if you look at the formula, we see exactly that. So we have sodium is 1, hydrogen is 2, carbon is 3, oxygen is 4. And again, we're not counting atoms here. We're counting total number of elements. We have 4 different elements in this compound. That's what makes this compound non-binary. Remember, binary simply means two elements. So you got to keep that in mind as you move forward. But if you do that, okay, naming these compounds, writing out these formulas for these compounds end up being very simple as long as you learn the rules that we use for naming binary compounds. We will use those same rules to name non-binary compounds. Okay? All right, so let's go ahead. Let's take a look at our first. Okay. So naming these binary compounds comes down to one very simple fact. Yeah, sure, you can say that they all end ATE or IT, most of them, but they all don't. Cyanide and hydroxide, they don't. Okay, so you got to memorize it. Okay, so there's no way around it. Okay, you got to make sure you memorize that table 9.3 in your book. Okay? All right. So once you have them memorized, though, the way that we go about writing out the names of these compounds, the way that we go about writing out the formulas for these compounds will be almost identical. So let's go ahead and let's start by naming these compounds first. Okay? So first thing you want to do, if you notice these questions are almost identical to the ones that we used to name the binary compounds, but we're going to use it to help us with the non-binary compounds as well. So first question, is this compound binary? Well, let's count the elements. You have lithium, that's 1, carbon, that's 2, and nitrogen, that's 3. So this is not a binary compound. Okay. All right. So now with that said, then look at the rest of it. Okay. We want to approach it exactly the same way. And that is name the cation. Remember, the cation will always be the metal ion, And if you notice here is the metal ion right here. So we have the metal ion right here. So we identify that. Okay. So lithium is our metal ion. So that must be the cation right there. Remember, all metals will always be cation. Okay. That means then the rest of this compound here, what we have right here. Okay. So let me go ahead and do this here. The rest of this compound right here. Okay. That represents then the anion. So the Cn is going to be our anion. Okay. So that's what you have to do. Identify the cation first, because that will be simple. The cation, again, will always be the metal atom. Okay. It will always be the metal in this compound. Okay. Again, with one exception. And we'll see that exception in just a moment. Okay. All right. So the name of this cation then, the name of the cation then is going to be the lithium cation. Lithium is a 1A metal, so it is not a transition metal, so we don't have to use the stock system. Okay. All right. So what is the anion now? Okay. The anion then is the Cn. Okay. The anion itself has this symbol, and hopefully you recognize and remember that it's going to be Cn minus. So which means then that the name of this compound is the cyanide anion. Okay. All right. So once we've identified the cation, once we've identified the name of the cation, once we've identified the name of the anion, the process then becomes simple. Okay, we drop the term cation, we drop the term anion, combine whatever's left over, and so we have the name of this compound then as being lithium cyanide. Okay, so the process is almost identical, okay, to what we did when we named the binary compound. Okay? All right, let's do another example. Okay, so I'll do this for you. Let me go through that out. Okay, let's take a look at this. Okay, and let's work on this together. Okay, so first question we want to ask then, is this compound binary? Hopefully you recognize and you see then that the answer is no, because we have then one element, two elements, and three. So this is not, I'm sorry, this is not carbon chlorine, carbon iodine. This is chlorine. So sodium, chlorine, oxygen. So we have three elements in here. This is not a binary compound. Okay? All right. So with that said, then it is an ionic compound because we have a metal and a metal portion here and this non-metal portion. Chlorine and oxygen are the non-metals here, but we do have the metal portion right here. And so let's go ahead then and let's write out the name of this metal. So we're going to go ahead and identify the metal here. And the rest of this here is the non-metal part. It's just now, if you notice, the non-metal part is made up of more than just one element. Okay. So with that said, then the name of the metal then, if it's a cation, then it becomes then the sodium cation. Okay. Sodium again is a 1A metal, and so this is not a transition metal. Okay. Okay. And so the name of the anion here, the anion is made up of chlorine and oxygen. Okay? And so the name of this anion then is going to be and so the anion here is going to be ClO minus. Okay, that is the symbol for the anion. We'll talk about that in just a moment. Okay, so this is going to be the hypochlorite anion. Okay, so we're going to go ahead then, drop the word cation, drop the word anion, combine together with whatever's left over. We end up with sodium, okay, hypochlorite. And that is the name of this compound. Okay. All right, very good. Let's go ahead then and let's do one more. Let's do one more here. Okay. And we'll do it together, and then I'll give you a chance to practice this. Okay, so let's do one more here. Let me save this one. Okay. Let's take a look at this. Okay. Let's go through this carefully. Let's go through this carefully and take a look at what we have. Okay. Right. So let's answer the question together. Is this compound a binary compound? Well, let's count the elements. Okay, so we have nitrogen, we have hydrogen, we have carbon, we have oxygen. We have four elements here, so obviously it is not a binary compound. But is this compound an ionic compound? If I didn't tell you that this was an ionic compound, would you be able to identify that? Would you be able to identify this is an ionic compound? It would be very difficult if and only if you did not memorize this right here. That, remember, is the ammonium cation. So there is your cation right here. So this is an ionic compound that has no metals in it at all, but it is an ionic compound because ammonium is the cation. Okay, and then we have this one right here, C2O4. If we that's going to be your anion right there. Okay, so what you have to do in this one then is you needed to memorize both of those, okay, and recognize then that the what we have there. So the cation for this one then is NH4 plus. The name of this cation then is ammonium, the ammonium cation, and it is the only one that you learned about. It's the only positively charged polyatomic ion. So you got to memorize that. Okay. So obviously this is not a metal, so this is not derived from a transition metal. Okay. All right, which means that the C2O4 is the anion part, so it's going to be C2O4 negative, and this is the oxalate. And so hopefully you had that memorized, guys. Oxalate anion. And as soon as you have those two ions identified, writing out the name then becomes very simple. Drop the cation anion portion of it and write down whatever is left over, ammonium oxalate. Okay. And you have the name of the compound. Okay. So naming these naming these non-binary compounds is not that difficult. It all hinges upon you memorizing these ions. You got to memorize these ions, because if you don't memorize these ions, it becomes then very, very difficult for you to identify what you're working with. Okay. All right. So what I would like you to do now then is, if you don't have, I want you to practice this here. Okay. I want you to, let's take a look at number 15 in your problem set. Okay. I give you 5 problems here. I would like you to take about 3 minutes, okay, to go ahead and name these 5 non-binary compounds. So hopefully, if I didn't tell you in the directions that these were ionic compounds, hopefully you should be able to recognize it. Okay. So what I'd like you to do then is, I'd like you to name these 5 non-binary ionic compounds. Okay, take about 3 minutes to get that done. Go ahead and get it done. Okay, let's go ahead. Let's take a look at this, guys. Let's take a look at it, see how you did. Okay, so we have then, I think for the first 2, I will go over each one of the questions with you, so you can follow along with this. Okay? But then afterwards, let's just go ahead and quickly go through and name them, because like I said, we're a little low on time, and I want to try to finish this up with you. Okay. All right, for the very first one, is it a binary compound? No, it's not a binary compound, because you have calcium, you have carbon, you have oxygen. You have 3 different elements here. This is not binary. Okay, so with that said, then, if it is not binary, is it ionic? Yeah, because you have a metal and a non-metal. You need to identify that. Why? Because the cation then is going to be the metal. So then calcium will be your cation. So calcium is a cation. Okay, and that leaves then the second part here to be the anion. As soon as you identify the cation, whatever is left over has to be the anion. Okay. All right. So let's go ahead then and let's name the cation. This is going to be the calcium. Okay. Cation. Okay. And CO3. Hopefully you got this right. It's going to be then we can combine that with the carbonate anion. Okay. And so therefore, when we go to name this compound, then, okay, we drop the term cation, we drop the term anion, drop those 2, okay, and we combine whatever's left over, and so we have then calcium carbonate. This is the stuff that we use in making cement. Okay, so that's calcium carbonate. Okay, let's go ahead and hopefully you got that. Please make sure you check your answers. Check your answer and see you got that as well. Okay, let's do the next one. Okay. And I'm sorry, calcium was not a transition metal, so we don't use the stock system here. No Roman numerals here. This is a 2A metal, no Roman numerals. Okay, let's go ahead and let's take a look at the next one. Is the next compound a binary compound? No, it's a non-binary compound, because we have lead, which is we have lead, one element. Oops, sorry. Okay. We have sulfur, the second element, and then we have oxygen. So we have three different elements in here. It's not a binary compound. Is it an ionic compound? Yes, it is. It's an ionic compound because of the presence of this metal right here, lead. So lead is the metal which means that it will be the cation, and whatever is left over right there, the SO4 is going to be then the anion. Okay. All right. So the name of the cation is going to be lead. Okay. And it's going to be the lead cation. Okay. The name of the anion then is the sulfate anion. Okay. All right. So there it is. The name of the cation, the name of the anion. Before we finish this up, though, is the cation a transition metal? The answer is no. It's not a transition metal. However, is it one of those 4 exceptions that you had to remember? And the answer is yes. Okay. All right. So with that said, then we need a Roman numeral in here. Okay, we need a Roman numeral in there to name it. Okay, so how do we determine then the charge on this lead? Well, it starts with the sulfate. It starts with the sulfate. We know then, how do we know? We know it because we memorized it. Okay, we have sulfate has a charge of 2-. The 5 atoms here share those 2 negative charges. Okay? Remember, with the polyatomic ions, we treat it as 1 unit. Okay, so all 5 of these is 1 unit, and they all share this 2 negatives. So the 2 negative charges, those 2 extra electrons that allow this compound to have a 2 negative charge, it's shared between all 5 of those electrons. That's what we learned about the Heisenberg uncertainty principle back in chapter 5. The electron, they just move all over the place. We don't know their exact location. So we say then that this sulfate, this is one entity, it has a 2- charge. Okay. This lead, if you notice here, there's only 1 lead. So we have 1 sulfate, 1 lead, which means that this 1 lead has to have enough charge to balance the 2 negative here. And so therefore it has to be a 2+ charge. Okay, so the lead is a 2+ charge, which means then in parentheses here, we're going to include the Roman numeral 2. Okay. All right, so to keep that in mind, you guys, you got to make sure you keep that in mind. The last thing we want to do then, in order to write down the name, drop the term cation, drop the term anion. Go ahead and write down whatever we have left. So this is going to be the lead 2 sulfate. So this is lead 2 sulfate. That is the name of the compound. And so the only difference here between this one and the previous one, calcium carbonate, is that we have then an ion, a cation, that has multiple charges. So we have to include the stop system. We have to use the stop system to name it. Okay. All right. So with that said, then let's go through the rest of this. I think we can go through this fairly quickly. Okay, this is not a binary compound. This is a non-binary compound. The cation then in this one is going to be K, which is potassium. Okay, this is going to be the potassium cation. Potassium is not a transition metal, so we do not need a Roman numeral. The anion here again is going to be sulfate. Okay, so this is the sulfate anion. Okay. And so therefore, dropping the term cation, the term anion, we get the name of this compound that is being potassium sulfate. Okay. And that is the name of this particular compound. So that's what we have right there. Okay, let's go ahead and let's take a look at the remaining 2 really quickly. Okay, so again, non-binary. Okay. Metal is the sodium, so therefore Na, which is going to be the sodium cation. Sodium is not a transition metal. Don't have to worry about the Roman numerals. We're not going to use the stop system. Then we have to the rest of it. Then, if sodium's cation, everything else is going to be the anion, which is going to be NO3. So it's a polyatomic ion. You got to memorize then that the NO3 is the nitrate ion, anion. Okay. Drop the term cation, drop the term anion, and so we have then the compound name as sodium nitrate. Okay. All right, and then looking at the last one, then let's go ahead and work through that one. Okay, so again, not binary. It's a non-binary compound, metal and the non-metal. The metal here is calcium, so therefore it's going to be the calcium, okay, cation. Whatever's left over, NO3, same thing again, it's going to be the nitrate anion. And so therefore, dropping the term anion, dropping the term cation, we get then the name of the compound is calcium nitrate. All right. So that's how you go about doing this, folks. And again, it starts out with memorizing the names of these polyatomic ions. You got to be able to do that. Okay. And then once you have that done, I think it ends up being pretty straightforward. As long as you have them memorized, I think it ends up being really straightforward because you can identify them as you if you see them in the formula. Okay. All right, let me go ahead and save this for you. And you know, uh, we're out of time here. So what I'm going to do tomorrow in tomorrow's video then is we'll finish up with this, and we're going to talk about then, now that we know how to write out the names, if we're given the formulas for these, whether it's binary compounds or non-binary ionic compounds, we should be able to write out the names. We need to be able to do that. What we're going to finish up with tomorrow then is that we will, if we're given the name of a non-binary compound, we should be able to write out the formulas that you have right here. Okay? And that'll finish out this unit on naming. Okay? And again, the skill that you acquire here is going to be very important as we move forward into the later chapters. So let's learn it here, learn it well, and that way then when we get to the later chapters, you won't have to worry about this because there's other things, new things you have to learn, and you don't want to be able to try to balance both at the same time. Okay. All right. Very good, folks. So I will see you tomorrow. Okay, and I'll see you tomorrow, and we'll take roll then. And please, if there's any questions on this, stick around afterwards and get your questions answered. Okay. All right, folks. Have a good rest of your day, and I will see you folks